You don't often see much woodworking on my channel. But in truth, my engineering journey started not with metal or microcontrollers, but with wood. Simple carvings and turnings at first. Then, over the years, my way of working evolved to include more materials and techniques. But every now and then, I still need to do a bit of basic woodworking. This is an ash board I've had for a number of years. I want to make a shelf from it. Unfortunately, it's been stored in less than ideal conditions, under a tarp outside, and it's become home to some unwanted guests. Though easily recognizable, these holes alone don't necessarily mean there are woodworm inside. They may have turned into beetles and crawled away, which can take up to 5 years. But if small streaks or piles of dust emerge from the holes, this is a sure sign it's infested. Sometimes you can even hear the worms chewing away inside. I'll start by trimming off the unwanted and worst affected parts. But I'll still need to treat it somehow to get rid of the woodworm. I don't really want to use pesticides, both because of the toxic effects and also I've had unreliable results in the past. But there is another way to deal with the problem. You're probably familiar with shipping pallets used to transport goods. Since these are often shipped internationally, it's very important not to introduce foreign pest species into areas where they could cause a lot of harm. In the past, pallets would be treated with highly toxic chemicals such as methyl bromide, but this has now been banned or phased out in most parts of the world. Instead, wooden pallets usually now go through a heat treatment process to kill any pests inside. If you've seen the letters HT stamped on a pallet, that's what this indicates. The heat treatment process involves heating the pallets until their core temperature reaches 60 degrees Celsius, and it is then held there for 30 minutes. This is usually done in a large gas or electric-fired kiln, but it can also be done with microwaves. This is a different process to kiln drying, which takes much longer. I already have a kiln that can easily reach this temperature, but it's far too small to fit this 1.5 meter plank of wood in. So I'm going to have to create a purpose-built kiln. Fortunately, as it only needs to reach fairly low temperatures, this is quite easy. I have these leftover polystyrene insulation boards. I'll build the kiln by simply placing the insulation boards around the wooden plank. For the heating element, I'm going to use an old-fashioned filament light bulb. This one is 150 watts. I put a metal shield above the bulb to avoid too much heat in one spot, and also added a small computer fan to circulate the air. I didn't have quite enough of the insulation boards, so I'm also using several layers of bubble wrap all around the outside. And yes, I'm doing this inside my greenhouse, where the ambient temperature is higher, to give it a head start. I'm using this cheap PID controller to run the kiln. This is really overkill. The temperature will change so slowly that I could easily modulate it manually. I'm really only using this because it measures the temperature with a thermocouple. A thermometer with a probe on a lead would do just as well. I place the thermocouple on top of the board, turn everything on, and wait. It took several hours to reach a temperature of 60 degrees Celsius. I could have sped this up by using more light bulbs, but it didn't really matter, as the slow increase meant the board was heated very evenly throughout. By the time it reached 60 degrees, it had already been sitting very close to this temperature for over half an hour, but I left it an additional 30 minutes just to be sure. An hour after switching everything off, and the board is still very warm to the touch. There doesn't appear to be any additional cracking or warping caused by the heat. The shelf has been in place now for several months, and the treatment seems to have been completely successful. There's no evidence at all of any woodworm remaining.